Well, hello, everybody. Good morning, good afternoon, good evening, good night to everyone, wherever you may be, somewhere across our lovely world. Thanks for joining us live here today. One and only Serverless Office Hours. We are streaming on the AWS channel. Thank you for joining us. Or if you're listening with the AWS events. Super happy about today. I'm Julian Wood. I'm a developer advocate who talks a lot about serverless at AWS, and we are diving deep into building agents with some of our experts who literally on the Strands Agents team. So, Arron, tell us about your history. How on earth are you working on the Strands Agent teams, and what made you join AWS?
Yeah, thanks everybody for joining today. My name's Arron Bailiss, principal engineer in the AWS Agentic AI organization. I work with Murat. Murat can say hi in a second. I work with Murat on Strands Agents, Agent Core, and I've worked on Kiro and several other Agentic AI products in the past. I have a history in dev tools as well. So that's me, and we'll be talking through a few things that are new in Strands today.
Cool. So you sort of started actually on the developer tooling side rather than necessarily the agentic side. Oh, cool. Love talking to developers who actually build developer tools. Awesome.
Yeah.
Murat, yes, tell us.
Yeah.
Introduce us to also Murat.
From my side, I have a shorter but similar background. Ed and I were in the similar dev tool space. We worked on web-based IDEs. And from there on, we moved into dev tools in agentic space, like we had QDeveloper, Kiro, etc. And from that use case, within that use case where we wanted to iterate and we saw how powerful the models were getting, we just wanted to come up with this model-driven approach and release Strands that we started using internally.
Excellent. Well, thank you both for joining. Just before, in fact, I'm going to hide that quickly because just before we go into that, I just want to talk about something completely different. Lambda micro VMs also came out today for our serverless aficionados. You want ephemeral sandboxes, coding environments, game servers, any kind of thing. Lambda micro VMs, do a Google search or Serverless Land for information. In fact, go to the front page of Serverless Land. You will see all about it as well. There's a nice little video explaining. But yeah, a whole new use case for Lambda. Micro VMs running up to 8 hours, lots of CPU, lots of memory. It's a stateless, it's stateful, not stateless, got persistent storage, runs up to 8 hours. What else did I want to say? Suspend, resume, all this kind of thing. So we will, of course, be talking all about micro VMs next week. So yeah, hang on for that. But yeah, super exciting stuff for Lambda. But yeah, back on to what we're going to be talking about this week. Friend of the show who was also on a few weeks' time as a superb guest, sort of sums it up. Hey guys, really like Strands, super easy to build agents with. So yeah, Arron, over to you. For people who don't know what is Strands Agents, can you sort of give us the big, the sort of overall elevator pitch? I was actually doing a workshop last week with Strands Agents to some developers who weren't necessarily even using AWS. They had never built an agent before, and I sort of live coded an agent in a 45 minutes in a whole talk. And a number of them came up to me afterwards, is that all an agent is? And I said, well, that's not all an agent is, but this is how Strands makes it super simple. So yeah, tell us about the genesis of Strands and what it does.
Yeah, well, I recognize Darrell's name, so thank you for the kind compliment, Darrell. Yeah, Strands Agents, so we have our website, strandsagents.com. It's a simple Python TypeScript library for building agents. Julian was just talking about some cool new stuff in Lambda. One of the nice things about Strands is it's all fully open source. It's just Python TypeScript code, so you can run it anywhere, right? Often we'll, Murat and I, when we're building agents in Amazon and AWS, we often start on our laptop, and then most developers will then eventually move over to production, deploying to Lambda, Agent Core, those kind of services. So one of the nice things about Strands is because it's fully open source and community driven, you're able to run it anywhere. Integrates with AWS and all kinds of other providers as well. But yeah, it just gives you that agentic loop where you have an LLM behind the scenes, calling tools, has your LLM model in a loop, reasoning about them, iterating over them to discover information and give you answers.
So it's not actually a service, because we talk about a lot at AWS of sort of services, and it has a page and something in the console. This is actually a developer SDK that you download from GitHub, you install and run in your application, and it abstracts a whole bunch of the sort of agentic stuff that you need to do to make that simple.
Yeah, that's right. It's there are several things. There's a harness SDK, which is what most of our customers and users are familiar with, the actual SDK for building agents, which we'll go through here. We have several other tools there as well. We just released a few days ago Strands Shell and some of the new features in the Strands evaluation SDK as well for, you build an agent, how do you actually know it works in production? We also have a few offerings like that as well.
Excellent. Well, Chase Granger, thanks for joining us via YouTube. I think Chase is excited enough for Strands that are looking to get some merch for Strands like we have at Kira. So yeah, maybe we have to.
It's funny, at a recent conference, the New York Summit, we had so many people asking for Strands hoodies. I think one of my colleagues gave somebody his. So yeah, we need to look into that. For sure.
Excellent. Because I mean, also the idea of Strands is connected to DNA correctly. So tell us something about the name. Yeah, the original name.
I mean, we debated internally many different names, but yeah, it comes from the twin strands. It's like the model and your tools, right? It's sort of what defines an agent. Put them in a loop. It's kind of like the helix shape, I guess. Strands of DNA. Yeah.
Awesome. And then just to reiterate, of course, it's going to work great on AWS. You can use the Strands SDK, model-driven, as may have been mentioned. Use any model, any provider, anywhere, run it anywhere. You can run locally on your laptop, literally absolutely anywhere, in a container, in a VM, in Lambda, in micro VMs, anywhere. So, and not even on AWS, can run absolutely anywhere. It's a software SDK.
Exactly. So one of the main topics we'll be talking about today is context engineering. So we'll be talking about all of these different things: summarization, compaction, offloading large tool results, some of the cool autonomous things. First of all, why do we care about that? So several reasons why we care about that. As we're building agents, especially longer running, more autonomous agents, they have limits, right, on how well they perform and how much it costs as they keep consuming information, right? As they're making more tool calls, making database queries, generating documents for us, whatever they may be doing, it fills their context window, right? And they have hard limits on the context window. So we've released several new things in Strands we'll talk about, but just wanted to cover why we think it's important first, I guess. So number one, beating context rot. Several models now, many of the leading models have 1 million token context window lengths. They still suffer after a certain point. If you have a model using 200K tokens versus 1 million, even if it can support 1 million, it generally performs worse as that context window fills up, right? You can think of it almost of like cognitive load. As you fill that up, the model's cognitive load increases. So some techniques to beat that. Avoiding overflow. So, that hard limit is a hard limit. If you hit 1 million tokens, you can't send any more information. So some techniques for handling that. Beyond that as well, there are costs to consider. Obviously, we all want to reduce token costs as much as possible. So some techniques for that as well. And we also found that it, increases accuracy, right? As I mentioned, cognitive load for the agent, but implementing some of these context management techniques we just released to Strands, you notice significant increases, several double-digit % increases in the performance of the same agent, essentially. So lots of important reasons why we care about context engineering. These are some of the techniques that we'll talk through briefly, and I want to definitely keep this kind of code focused, so I won't bore everyone with too many words, but we'll jump into the idea in a second. But to talk about some of the things we're going to be digging into, summarization and compaction, some people may be familiar with this already. We'll go through these all in detail in a second, but it's taking the current context window and compressing it, essentially. We use an LLM, give it all of the context and say, hey, summarize all of this for us, please. And that's the new model's context. So that we call that summarization or compaction. There are offloading large tool results as well. So if we, read, I don't know, a 50 megabyte PDF file, perhaps, it can also fill the context window, right? So there are some techniques there for offloading these large tool results. Maybe we make a database query and it returns a huge JSON payload, right, for lots of results. Some techniques for managing that as well. Some autonomous techniques, agentic self-management. We have the model controlling its own context we'll dig into. And Murat will talk about a few things as well for progressive disclosure with agent skills and the agent managing the tools that are available to it dynamically on demand. And last couple of things, adjustable thresholds for everything, right? Strands, we've tried to keep it very developer focused, right? Simple first, but you can customize everything. Everything is exposed. So you can customize that. And finally, memory systems as well for also offloading context in a sense, longer term. So those are a few of the topics. Our first one, some people may be familiar with this, summarization and compaction has been around for a while now in the agentic AI space. So here we see on the left, this beautiful colored diagram I made earlier. We see imagine this is the context window of the model. You have, at the bottom, we have the system prompt, which is part of that context, the tools specifications for our model. It might be some tools to query our Slack messages, my emails, that kind of stuff, maybe read, write files. I have user messages, which are, things I'm typing to my agent. And then we have several things in a chain there, right? The model asking to call tools like, hey, I want you to edit this file with this content. The tool results, if we're reading a large file, the actual content of that file, and that loop continues and it just keeps stacking up and appending to the context window. And as you see, have this red line at the top. Imagine that's, perhaps with some of the latest Claude models, 1 million tokens, the max context length. That's the red line here. Something we've introduced to Strands now, proactive summarization. So you can set a threshold. Here we see it's 85%. When that threshold is hit, we make another LLM query for you. You can customize the model there as well. Use a cheaper model, maybe Haiku or something, right, instead of Opus perhaps, to summarize that context for you, which is what we see on the right here. Much less of that context used, and it's all in that summary block, basically compressing the tool calls and previous messages.
Yeah, one thing I'd like to also highlight here is all of these items that you see in the context, they are essentially time series, right? It's a user asking a question, tools, and then model answering, and then this iterates. And when you do actually summarization and compaction, you don't necessarily want to touch the last part of the conversation so that the conversation continuum happens. What you generally do is, let's say at 85%, you summarize the first 50%, and also leave some references so that the agent can continue and can still access the source of truth and can continue the conversation as it was just the previous turn.
It's like does that agent call just have to be clever in there's a recency bias of, keep more of the stuff or the older stuff I don't care about? Because sometimes you're going to say, well, you got a tool result, I'm going to run the tool again because I had an incorrect result. So that, you don't even need the first tool result in your context. Does it just figure it out?
Yeah. So we'll get to that part later when we talk about more agentic techniques, where we essentially give that ability to the model. And in that scenario, the model can figure this out. What we offer in the SDK are actually two modes. The auto mode is more the defaults that we set for you so that as you use it, your agent just works, versus more the agentic methods that we're going to talk later, where we give all those abilities to the model so it can figure out, so it can manage its own context.
So there are two modes, auto and agentic. You see here in the green text at the top, context manager equals auto. You can now define that on your Strands agent. We'll jump into the code in a second. And it will automatically set up this proactive summarization for you. You can customize it as well. So that's summarization. There are also large tool results, right? So you can imagine maybe you have an agent making database queries, searching for things in a database, right? Maybe I have millions of records. Maybe 200,000 of them are returned for my query. Putting all of those 200,000 results into the context window, as we see here in this diagram, overflows the max limit that we have and breaks the agent. So as we go through and tool calls build up, some of them can be very large. So something we've introduced to Strands as well in the auto mode, again, context manager auto, you see at the top. This offloads those large tool results for you. How this works, so you define thresholds, or you can just use the default ones, where when these tool results are over a certain token size, instead of putting them directly into the context window of the model, they're saved externally. Essentially, they're offloaded. By default, this is in memory. In the code we'll go through, this is using the file system. You can use S3 or any interface. Again, Strands is fully customizable and open source, so this is an interface you can extend as well. It offloads that context to this separate storage, and it gives the model what it actually puts into the context window is a small preview of the content, and a reference to where the agent can find the offloaded tool result. So if it's in a file, that will be the file path of where the agent can find that file. The agent is then able to query that file, maybe use grep and cat and find and those kind of tools, right? To look through the file's contents without having loaded everything, right? Instead of those 200,000 rows, it can do a grep for something interesting that it's looking for, and maybe it loads in 5 rows into the context instead.
And then that grep would also be much cheaper because it's just querying S3 or something in memory or a file. It's not actually doing even an LLM call to do that.
Yeah, the model would make the request to do the grep or the retrieval, but yeah, the actual running of that, it's just a tool call essentially. Yeah. Like with the in-memory default offloaded storage here, what we add to the agent a tool so it can retrieve that from memory. In Python terms, I think it's just a dictionary that we store, right, in memory. The agent is able to retrieve that with a retrieval tool. With a file system, right, your agent is able to use some of the built-in file read tools that we have in Strands. With S3, you could use the AWS SDK there, right? If it's a custom interface as well, whatever mechanism you need to read. So that's Context Manager Auto. Two new features there: the offloading of tool results and the summarization, proactive summarization. Several built-in tools in the SDK as well: file reads, edit, that sort of stuff.
We do have a question which is related to this from nice name, Tamed Craziness. What do you do with the tool calls and the tool results? I think it could be, and we did cover that, but I think it could be better utilized by a sub-agent for validating and iterating the main agent skills tool use. So I suppose that's an architectural decision of, are you running your agent in this single agent loop or spinning off to other sub loops to do that kind of thing? And I suppose it depends how much isolation you want to give them. But ultimately, this is in a way going to do the same job. If you went off to a sub-agent and had a huge big database query, well, that context in the window in the sub-agent is going to be filled up. Maybe that's not going to fill up your main agent, but I would think the same concepts apply, just in a segregated sub-agenty way.
Yeah, so we've built a bunch of things for delegating subtasks to agents, right? In Strands, we have a use agent tool. Just dynamically spins up like a clone of itself essentially, and can copy over the settings you have on your Strands agent. So if you're using this context offloader feature, the sub agents also inherit that. It is useful for every agent, right? Like even a sub agent can overflow.
Yeah.
Whether you want like multi-agent or not, I would say is something that depends on the use case. You should evaluate that. It can improve things on some of the dimensions that you mentioned. However, it does introduce a lot of architectural complexity as well, right? For example, if you have a primary agent delegating to the sub-agents, there's now like an additional communication layer there, right? And it's an additional surface area where, you know, your primary agent can miss information when it's sending it to the sub-agent perhaps. But, you know, it does work. As well, of course, to have the multi-agent, sub-agent style architecture.
Yeah, I think.
Do you think sometimes people overdo it on sub-agents when they think they need fresh context windows, and maybe that's going to be a good idea, and maybe they've got different things?
I'm guilty of this myself, yes.
I disagree. I think like this is more where you need to understand your use cases and like exactly what you want to do. You don't want to use sub-agents for everything, but you want to use sub-agents where you have like these sort of self-contained tasks where the input and output are what you care, and sort of you don't necessarily care about everything in between. Couple of examples that I always create sub-agents for are like, for example, research, right? I don't want my main agent to read all the HTML and unnecessary information. And then another one is a reviewing, where you might have more, like you actually want to start with a clean context. Right, you don't want all the previous knowledge and information. You want to start and do your own research and evaluate it yourself. And like this is where you need that. You make that trade-off. Like if it's a self-contained task with a fresh context, that's like the sub-agent. But for the most cases, you also want this like context manager auto in all of your agents, sub or domain.
Yeah. Okay, Murat, you want to? So what we just described was auto, right? They are deterministic mechanisms for managing context, right? Summarization, you know, at a certain threshold, the Strands harness will run that summarization for you and manage the LLM's context window from there. Same with the tool result offloading, right? It's like a feature of the Strands agent harness, the SDK. Murat's going to talk a bit more about more autonomous ways of doing that kind of stuff as well.
Yeah. So we start with the auto and we want to take it further, right? We've talked with Julian about what if you want to give these capabilities to the model. And for that exact reason, we've also brought the agentic mode. Before we get started, I think one thing I would like to highlight is even with the agentic mode, we use auto and auto capabilities as backfall. Like in case we still go back about 85%, let's say that's the threshold, we still run the summarization. So we don't let agent, you know, overflow just because we didn't explicitly set these things. But what we do on top is give it additional capabilities so that agent can manage its own context and keep track of what it needs to know and what it can discard. To do that, we give it a couple of tools, right? And these tools, for the most part, they match what we do for auto. So for example, summarize context here, right? We give it a summarize context tool, just like the summarization that we have, so that the agent can say, hey, like take the first half of my conversation and summarize it because I don't need it anymore. I just need to know the highlights. Or it can say truncate the context because, well, I don't even need the highlights. Like, let's just get rid of it and we can focus on the next task and fill up the context with those. And while you're doing this, right, like you lose messages, you lose information. So it might be tool results, it might be skills, instructions, etc. And that's where we've also bring the pin context as another capability that the model can control.
It'd be like the first message I send to my agent normally is, it depends how verbose you are, right? When you talk to your agent, if it's, let's say it's a coding agent, right? I'm super verbose on the first message. So it contains all of it's like a gold mine, that first message, a lot of valuable information for the agent there. So it keeps that, right? It pins it there and doesn't remove it from the context window. Exactly.
So the agent can control it. And I think agentic context management is especially important when you're running autonomous agents that are tasks with like long horizon tasks where it might need to go for an hour, it might need to do its own research, implement, deploy, run a maybe review of agent and iterate, etc. Right, where it's going to have all of these huge build artifacts, logs, the data that it gets from services, APIs, etc. in its context along the time. But after 2 messages, that data becomes stale. So what the agent would do is it pins the necessary messages and it keeps truncating and summarizing the unnecessary context.
That's another good point. For the tool result offloading, things, when coding agents are running builds or running tests, they can have very verbose outputs. It's really useful in that scenario.
Exactly. And for that tool result offloading, I generally give the example of searching for logs, right? CloudWatch logs. You don't necessarily go into log groups and read all of the CloudWatch logs, even as an engineer, before the agentic era. You would just search for errors and warnings, etc. And that's exactly what the agent does.
Search for the exception keyword.
Exactly.
Yeah.
Right. We can continue on. So when we're building on agents, essentially, we've started Strands with what we call the model-driven approach, where our idea was we want to give these capabilities to the models because models are getting smarter, and we want to essentially let them manage it for themselves, right? That's why we have the agentic context management, and that's why we also have the agent skills integrations, where we essentially invest into more model-driven behavior and what I call instructions on demand. So it's more the progressive disclosure. So the idea here is not about necessarily getting all the instructions ahead of time, but writing the instructions and letting the agent decide when it needs those instructions. So if it's doing a review workflow, it needs the reviewing instructions. If it's doing an implementation, it needs a different set of instructions. And for that, we also provide agent skills as an integration Strands. Most of the developers might have used it, right, with your coding agents. Similarly, you can add these to your Strands agents so that they get the instructions just when they need it and they don't blow up the context.
So with the agent skills, like on the left here, in the context window, you see we have the usual stuff: system prompt, tool specs, the user message, my first message to the agent. It also has skill metadata, right? Which is you have a skill.md file that has the name, has a brief description of what the skill does. Then it has like a big line separator and all of the content for the skill, right? And initially, the only thing that is loaded into the agent's context is that name and description. When the agent wants to load the skill, it calls the skill tool. I think Murat built a lot of that stuff as well, so he's the right guy to talk about it. It uses a skill tool to load that full skill.md content. So now it has, as we see on the right here, the PDF instructions, right? Those are like the skill.md instructions. So it doesn't have the PDF instructions initially, but it can retrieve them dynamically and load it in on demand, right? So if it doesn't need the PDF handling instructions, it doesn't load them, right? So you save a bunch of costs and tokens. It's faster, and as I spoke about earlier, that cognitive load is less for the LLM, for the model as well. Okay, that's agent skills. So we have on the strandsagents.com website as well, documentation for skills, context offloading, summarization, the agentic and auto mode as well.
Yep. And before we get in there, one thing I'd like to also highlight with Strands is we provide like these sort of context manager auto and like high-level integrations, but all of these are built on the primitives we provide, where you can just use it yourselves and configure it, which becomes especially important when you want to go from a demo that you build for yourself and show off to your team to a productionizing the agent that gets used 10,000 times a day, right?
Okay, tell us about dynamic tools, Murat.
All right, dynamic tools. So again, so this is more on the context problem, but as we give as the models get better and better, and we give them more tools, right, because they can do a lot more, and we can trust them with a lot more, they end up with these like hundreds of tools that they load in it. Especially this gets exacerbated with the MCP servers, etc. that we load, that might bring in 50 tools, 60 tools, hundreds of tools behind the scenes without even you realizing. And to solve this problem, again, in a more agentic way, we've integrated with Agent Core Gateway, and we've added tool searching capabilities, right? So what you can do now is, using Agent Core Gateway, you essentially create your toolkit, all of the tools that you might want to give to the agent, and this might grow. But along with that, what we give to the agent is a search tool, so that the agent can search for what it needs dynamically and get the tool specs it needs exactly when it needs them. So you can think of this as what agent skills are, but applied to the tool spec and tool description, right? So we want to do progressive disclosure, and we won't want to confuse the LLM too much.
It's sort of like we were talking about the tool result offloading. This is like preemptive tool spec offloading, right? It's like on the left, we have 100 tools in our agent. It works, but it's expensive for us, it's slow, and the agent isn't as accurate and performant as it can be. So we offload that to Agent Core Gateway in this case, and that we have a plugin for Strands Agents that enables this tool search on Agent Core Gateway. But we just offload all those tool specs, right? We put them in a different storage that is not the model's context window, in this case, Agent Core Gateway. And then we give the modeler the ability to kind of search that external storage, right? Exactly the same as with the offloaded tool results, where it could grep for information within a file that it offloaded to. Same thing here. It can search for tools that match the request rather than loading all of them at the same time. Okay.
We did just have a question, which is slightly earlier, from Chase Granger. Thanks for joining us. If both Auto and Agentic Context Manager, back to the context, modes are hands-off and use an LLM to summarize, when would you intentionally choose one or the other?
Go ahead, Murat.
That's a good question. Yeah, so I'll go over my mindset. I generally want to go with Agentic Context Management when I have long horizon tasks where, like, sort of this building step and agent managing its own context is rather important. And it needs to keep track of tasks. It shouldn't forget them. And like every time you do summarization, you might lose some part of it. But I use Auto when I'm, for example, focusing more on chat agents, where I don't want the added latency and added tool calls from the Agentic Context Management, because what I'm doing is more focused on the last couple of actions, and it's not a long horizon task. And that recency bias just works in my favor. That's generally my mental model while getting started, but I would of course recommend you to try out both. Use our Strands Evals to see which one works better for your use case and go with that.
Yeah.
Cool, excellent. And you, carry on, Arron.
I was just going to say a lot of what I've learned, I'm sure Murat will agree, in the agentic AI world, is I'm obviously biased here, but with frameworks like Strands Agents, it's very easy to build like a very powerful agent, super easy to add like an extra tool, super easy to enable the agentic context management. So what we do internally in Amazon and AWS is we experiment a lot, right? We build many different copies of the same agent and test all of them, evaluate all of them. Cool.
You're certainly getting some more love. Sally Gello, who's an absolute friend of the show and an awesome colleague, and TypeScript and Agentic Guru. The workshop last week he was heavily involved in. Strands TypeScript has been a big part of my day-to-day agent building, which is great. And then Tyco Dev, I think, thanks for also joining us via YouTube. The best SDK we've seen so far. We tried 3 alternatives, but none of them gave the same flexibility and confidence level Strands does. So it's not just us talking about it. We've got other people who enjoy it too.
Awesome. Thank you. Yeah. Okay. So we hop back down here. So yeah, we can go into some code now. There's a small little snippet here on the left. I'll share the link and stuff in a moment with a QR code if anyone wants to follow along. But we can see just a super simple code snippet here. Those of you that are familiar with Strands already, this won't be anything revolutionary, but you see we have the context manager equals auto, right? In our agent definition here. Just one line enables all of the stuff we've just been talking about. You can set it to agentic mode to have the agent manage its own context window. Yeah, so we'll go into a few of these. We, besides all the context management stuff, which we've been working on making a lot easier, to make real state-of-the-art agent harnesses, similar to Kiro, Claude Code, Codex, Open Code, those kind of harnesses. We've also released a few other things with Strands. So we have a Strands Shell, which Murat will talk about in a moment, and Strands Evals as well, right? We went 1.0 version with that. Introduced some new features for chaos testing and red teaming. So we actually have an agent that goes and tries to break the agent that you're building. So that's a nice little feature there. You can make sure your agent is working how you want it to before you deploy to production. QR code here. If folks want to follow along with the code, we published this to GitHub. Kudos to Ryan, my colleague who built this little Pokemon team advisor. I'll show you in a moment. But yeah, if you go to the Strands Agents GitHub in the samples repo, you'll see that directory there, Python. It's the number 5 samples, and there's the Pokemon team advisor. So this is the repo we'll be using. If I switch over to my IDE. Yeah, so this is the repo. I have it checked out here. This is that Pokemon Team Advisor sample. Little readme. I already ran the setup, so it downloaded some information from the Poke API, about 400 megabytes of information, JSON files. Like if I look in here, you can see all this information, right? All these JSON files with all the abilities and stuff for these Pokemon. I just run this script to run the agent, which I'll jump back to in a second. And we also have an eval script here, demo evals. We can jump into that. This does some of the chaos testing and red teaming I mentioned. So yeah, please feel free to follow along as well and afterwards. We have Discord as well. Happy to take questions there afterwards, or obviously in the chat now. But this is what we're running through. So if I hop over to the demo agent, yeah, so this is the good stuff. Here's our agent here, line 48 to 58. We import this agent class from Strands. We're using Python here, but of course we have some TypeScript fans in the chat I saw. So same thing in TypeScript, very similar interface, same feature set. This is our agent definition. We give it 3 tools. We have a get Pokemon and a get move tool, which are custom tools I'll show you in a moment. And we have the Strands Shell tool, which we recently just launched. You'll see I'm running that as an MCP server here. You can use MCP tools very easily with Strands as well, but we're just running this Strands Shell. This is a command. If I hop over to my browser over here, I'll just show you the Strands Shell repo. Yeah, so this is a new repo we launched. It's like a born compatible shell that runs in process. So it's almost like a virtual shell.
Essentially, this is like a virtual shell, right? You want that you can give to your agents. The main benefit of this is, right, that when you're running your agents locally or in your runtime environments where you have all their credentials, your secrets, other processes that are necessary for your servers, you don't want agents executing code there, executing shell commands there. And what we do with Strands Shell essentially is creating a virtual shell, a virtual environment with a virtual file system where the agent can go and run commands, run batch commands like curl, JQ, grep, etc. And the agent can still get through its task, but it doesn't necessarily touch your runtime environment with all the secrets and your own agent process.
Different layers of sandboxing almost, right? And we'll talk about that in a moment. We also just launched sandboxes in Strands, but you see here, right? There's like Docker container-based approach. There's cloud sandbox, micro VM approach, maybe using agent core runtime. And then Strands Shell, which is an in-process virtual file system, right? And they all come with various different benefits of performance, capability, and security as well.
Exactly. And for the Strands Shell, I'll call it more of a in-process mediation layer, right? It's not necessarily like a full sandbox like Docker is, but essentially the way it works is you give the shell a strict command, and we have implementations of these commands where it uses a kernel trait that we've defined. And everything that flows this kernel trait, so it's like reading file, writing file, changing the file system, making HTTP calls, etc., we can control and limit. So we can say through the shell, through the curl, agent can only call these endpoints. Or let's
have an example of that. Like in this sample, we have this sandbox TOML file, right? It defines the policy for the Strands Shell, essentially, which directories are mounted in the shell and the access level to them.
Exactly. And additionally, you can, for example, inject credentials during HTTP request time, right? So that you can say when the agent is calling api.example.com, you can inject this API token environment variable as a credential, as a bearer route token. So this allows your agents to still make the API calls, but never actually be able to see the credentials that are used to make that API calls. So it gives you another layer of security.
Yeah, it's like I run tons of agents on my laptop. I do not want them to have any of my credentials, but I want them to be able to access some of my files on my laptop, right? So it kind of encapsulates all of that. Supports Node.js, Python. Anyway, so we have the Strands Shell there. I think a link was shared for the sandboxes. We just launched sandboxes in Strands. There's this sandbox parameter as well, right? With a couple of built-in sandboxes. So we have Strands Shell as the in-process version. There's, we have a Docker sandbox. We have a Docker sandbox and an SSH sandbox, right? So you can have your agent, when it's writing files, reading files, it works in a separate Docker container or a separate SSH host, perhaps. Or with Strands Shell, it works in its own separate virtual shell process.
Yeah, so what we essentially do is we give bash and file editor commands and some related commands that under the hood run the commands in that sandbox environment. So when you use the bash command to execute grep, we just route that command to your Docker container and execute it there and return the results back. So what you do is you have this split and safe agent execution environment, right? More of an agent workspace. And then you have your agent runtime essentially safe and sound from any risk that might happen in the sandbox environment itself.
Yeah. So a little code snippet here for that. So yeah, back to our demo. We have the shell tool here. We're using context manager auto mode. You can see, we could delete these lines here for these plugins. And now we'll just use the default settings for the context manager auto mode. I actually want to change a couple of settings. So I'm changing the context offloader here, right? Instead of the default being an in-memory offloader, I'm actually getting it to store in a file system here. So that's our agent, right? We have a couple of custom tools here. We have get Pokemon, get move. It's just reading files from a couple of directories. That's it. I ran this script earlier So you see here, I ran uv run demo agent.py. If you run the setup script and run this, it will set everything up for you. If you have Bedrock credentials, it will run. And we can see here the agent was just running through the task that I gave it, right? It's running through calling different tools. We can see it calling the shell tool here. If I look at the task I gave it, I asked it, I'm building a competitive team and need a physical attacker with good coverage. Which Pokemon can learn both Earthquake and Ice Beam that has the highest base attack stat, right? So agent went, digging through all of this information. In the shell tool that we just showed, it has JQ and Lua available. So it was using JQ to extract information from the artifacts directory. Right? Remember, we bound the artifacts directory, so the agent can read that. If we didn't add this, it would get an error saying that directory is not available. So because we added this, the agent can access this. So it starts reading through, grabs all the information for me, and eventually I get my answer right. And we can look at some of the traces to see what actually happened. You'll see I customized the offloader, right, to store in this artifacts directory. So I have /artifacts. We can take a look in there. And here we see when the agent was, calling all these shell things with JQ, right? I mentioned it's 400 megabytes of JSON data in the PokeData directory that we showed at the start, right? These are the actual tool results, right? So if we look at some of these, we can see these are the actual JSON files that the agent was reading. And because they're large, it offloaded them, right? Like this one is, tens of thousands of lines. We can see all of those artifacts here. So this is where the agent has offloaded them to, and it's using JQ to read through these files. Essentially, it could be grep, but it's using JQ in this case because the shell tool has that available. So those are the offloaded artifacts. And if we go back to my terminal, here we got the answer. I mean, this is just a demo use case for our Pokemon fans. Maybe this is interesting. But what I find more interesting, because I'm an agentic AI person, I love Pokemon as well. But here we have, 38 offloaded artifacts. I added a little thing at the bottom of our script here. Just prints the offloaded artifacts, right? And it also prints agent.messages. So agent is, our Strands agent that we defined earlier. Agent.messages is that context window that we've been talking about, right? So it has like the user message here. Here's the message I sent, right? That task that we asked it to find a physical attacker, blah, blah, blah. Here's the model's response. Here it started calling get move and for the earthquake move, right? All of these things, we can dig through all of them. Here we see it started trying to read some of the files, right? Making mistakes there, it corrected itself, blah, blah, blah. And as we go on, we can keep seeing where it's offloading tools, calling JQ, right? It's in fact hit an error when it called JQ here. So it tried again and corrected itself, all of that kind of stuff, right? We can see some of the offloading and that kind of thing here. Just everything is in that agent.messages, right? All of the tokens it used, the latencies, everything. So that's mostly the agent script, right? It shows pretty simply how some of these improve things. And now if I was to, if I remove these and reran the agent, for example, it wouldn't perform at all, right? Because those large JSON files, right? It would try to read them and just immediately fail, unless I give it tools to be able to grep or read them at a more granular basis, right? It will fail. So
or depends on the model, right? If you give it a huge model that can get a large context, then you might be able to get it to succeed, but it's going to be slower, less performance.
And you're paying for that.
Cost you more money. Yep.
Exactly.
Exactly. So this was the little demo agent script. Honestly, nothing complicated, 70 lines, right? The main thing is this piece here where we're defining the agent. You can see we can customize some of the things that the auto context manager strings together for us, like the context offloader. We spoke about Strands Shell. There's also evals. I won't dig into this too much in this call. I think we'll probably do a follow-up live stream at some point in the near future on a lot of the evals features.
It deserves its own live stream, I think.
Yeah, but do have a dig through the demo evals. You'll see there's a Strands Evals package, right? Exactly the same sort of philosophy as the Strands Agents package, really. But here we're helping you do evaluations, right? So this script evaluates what we just saw that demo agent, right? This demo agent we've built here. This demo evals actually validates its outputs. So like in here, you'll see, yeah. So we have API data, Poke data. Those are all those big JSON files for, you know, all the different Pokemon, all of the moves that they are able to learn, all of their stats, that kind of thing. What we're doing here with this chaos testing is we're introducing incorrect information or bad data, right? So here, for example, you can see we're introducing an error to some of our tool calls, our demo agent, sorry. We're adding some errors into it, right? We're adding like a HTTP timeout error, a connection error. And we want to see how the agent behaves when those happen, right? We do not want the agent to give up and say, oh, there's a HTTP error, sorry, I can't answer. We want it to be, you know, robust and continue and try to work around the problem, right?
So is the evaluations basically Chaos Monkey, and in a way we've got fault injection simulator, which is a service, but this can do similar things in an SDK. It's not just input and output of what the model does, but affecting things like network errors and timeouts and that. I didn't realize that.
It's so in that context window of the agent, right? It's injecting like Chaos Monkey style faults into that, right? So it will, you know, if the agent calls the get move tool here, the response, the simulated response, right, is a HTTP timeout error. So then we can, you know, simulate essentially how the agent behaves when that happens for real. We can simulate that locally before we deploy, and, you know, make sure that it actually works before we deploy.
Yeah. And similarly, I think we also have the red teaming here, right?
Yes.
Which, honestly, I think for me, that's been the game changer, especially with our own team code reviews and when you develop agents, etc. What we've found is asking an agent if the code you wrote is good or not is not as reliable as asking an agent to go and try to break it for 1 hour, right? Approach from every angle, try to give random inputs, try to read the codes and break it. And when we run these agents, like they can take hours. And these were the long horizon tasks that we're talking about with the context management earlier. And what the agent essentially tries to do is it tries to break your guardrails, your system, etc.
Give it a goal, give it the success criteria.
Exactly. So you give all these criteria, and then you have another red team that essentially tries to break your system and give you actual validatable artifacts, right? Not necessarily just, oh, hey, I read this code and it might be broken, but like here's an input that actually breaks your system, and this is how we've observed it.
So it's also using an agentic natural language way to run to in fact form your tests. So obviously you could use AI to build a whole bunch of test suites which could test all of these kind of things, but that's going to be quite deterministic, which could be great in some scenarios. But you actually, you know, get the agent to use the shell tool to read or list files outside the artifacts directory. I mean, you're not actually writing a test for that. You're writing a sort of an agentic AI way, which is then going to red team. I hadn't even realized that. That sounds like a great idea. I hadn't even thought of that as a sort of possibility of red teaming using your AI against your AI. Very Inception.
Yeah. So a couple of new features there. Strands Evals. Strands Evals you can use with various different agent SDKs as well, right? It doesn't just have to be Strands agents. But yeah, the idea here, chaos testing to inject faults and things into your agents before those faults actually happen, basically running simulators. And yeah, the adversarial testing here, as Murat mentioned, right? It's you can imagine it as an agent trying to, attack your other agent, that kind of stuff. Like here, as Murat mentioned, we actually ran this against our Strands Shell tool to try and break out of it. I think that's most of what I wanted to share today.
Awesome. Chase has just asked, while we were on that, can you run Strands Evals using local models to save money on repeated agent runs? I would presume yes, because you can run it against any model anywhere.
Yeah, you can configure the models as well. So, whether you're using Claude or Gemini or GPT or, some local models with Llama, perhaps, right? That kind of stuff, some Quen models, whatever, all supported. Yeah.
Cool, excellent. And then Tamed Craziness is coming back when we were talking about the Docker container. Similar to how GitHub Codespaces is allocated a VM with a Linux OS Docker container, and then went on to say it's defaulted to Bash, which is undesirable. It requires installing other shells that are application specific, which can be a headache. And my thinking is it's a Docker container. You could literally run anything in it literally up to you, any OS, anything. You're just spawning out to a Docker container. I think this was to compare against the in-memory approach, or the shell using the Docker version of the shell, which I suppose could be anything.
Yeah. So with respect to the containers, essentially what we have in the Harness SDK is a Docker interface more than Docker container itself. Right? It expects an already running Docker environment, and it provides like a Bash tool that comes out of the box. But all of these can be customized and overridden. We also explain all of this in our documentations, where we can use like tools like make bash, make file editor, etc., where you can adjust the tool description, the name of the tool, which sandbox it uses under the hood, etc. So you can customize the tools that the agent sees for the exact environment that you're running for.
Yeah, like these are a couple of the default tools. You can customize those as well.
You can create your own tools that use sandbox under the hood.
Yeah.
Excellent. And yeah, Victor, thanks for joining us via Twitch. Also, was just talking, I don't know what other stable product have another sandbox with no red teaming needed anymore. My feedback on that is, sure, there are going to be many sandbox technologies, and it depends what you want to test. If you're using a cloud sandbox or even Lambda micro VMs, we spoke earlier, maybe you don't need to test where to be able to break out of the sandbox, but there are going to be many other tests you want to run to see that your code working as well. So yeah, just depends what you want to do. There are many layers in this pie of what you're going to test. Yeah, and my sort of meta comment as we wrapping up here before we do have the most important comment that has come through of the day is this is such an interesting space because in terms of even a software architecture point of view, it is really sort of understandable but very different on building agents and deciding what they do, because you do need to manage context, you need to manage your size, you need to trim things, you need to run agents, you need to, things in memory, sandboxes, shells, all these kind of things, which people aren't used to doing. So it's a different way. It's extremely powerful, but it's a different way. And I'm sort of happy we have the Strands SDK to at least make that happier, because what I've been playing, the documentation is pretty good. Discord server, which you've got the link up over there. Yeah, good job. And just before I said, the most important question that has come in from Eerie Edits, thanks for joining us again. If you were going to turn an agent to a Pokemon, which would it be? Anyone an expert on enough to be able to pick that?
Pikachu is my favorite. It's a lot of childhood nostalgia from Pokemon Yellow on the Game Boy. So
definitely got to be a classic.
Yeah.
Excellent. Well, Arron and Murat, thanks so much for spending a great amount of time over here, and everybody watching. Super pleasure to have you. I think lots of information. Strands Agent is going like gangbusters when I talk to people, out in the field of my job. People are loving it, so that's always great to talk. Tamed Craziness agrees. I'll continue researching Strands. We appreciate that. So yeah, Arron, Murat, thanks very much for your time today. Love to hear from the engineering team who's actually building this. It's a pleasure to have you. And so for everybody else, we'll see you same time, same place next week, talking micro VMs. Bye-bye.